Welcome back, guys. We're going to look at Unit 5, Section 3, which is basically just about sine and cosine, maybe a little tangent. Let's just start. From the information given, find the quadrant in which the terminal point determined by t lies. Okay, so here's what we need to know. I've heard this done a few ways, but I'm going to teach you the way I know it. C-A-S-T. And I just remember the word cast, right? C-A-S-T. Some people like to say all students take calculus. I've heard that one before. You know, there are a few different ways, but I just remember C-A-S-T, and I know I have to start from this one. And what that really means is that okay, so the point P is on the unit circle. If the y-coordinate, so here's my y-coordinate, is -3/7, and P is in quadrant 3, that's this quadrant, then what is x? And we know it's on a unit circle, so the radius will be 1. Now, that means that this distance here is 3/7. Right, because we had to go down 3/7 to get to that point. We knew the y value. So what's the x value? Well, let's just use the Pythagorean theorem to figure that out. So x squared plus 3/7 squared is equal to 1 squared. And if you're wondering how come we didn't use a -3/7, that's because we can't have negative distance. X squared plus 9/49 is equal to 1 minus 9/49 on both sides. And we get x squared is equal to 1 minus 9/49, which is 0.81 63265. Now that number doesn't matter because I'm going to take the square root and I'm going to use a number that's stored in my calculator. So second square root of second answer, and we get 0.90351. Going to round to that place. And you can see that that's the answer they have, except they have a negative, and that's because x, the point isn't, it's a point, and we have to go backwards on the x-axis. Cosine of theta is -7/9, and theta is in the second quadrant. Find the exact value for sine of theta. Okay, so basically they're saying if the x-coordinate, right, if you have a unit circle, show that unit circle, second quadrant, let's just draw that line, this point. They're saying if the x-coordinate of that point is -7/9, right, this is theta, this is my right triangle. They want to know what sine of theta is. Sine of theta just turns out to be this number here, your y value. So let's kind of do that. So we know this distance is 7/9, and we don't know what that is. So the Pythagorean theorem. Well, maybe calling it y would be nicer. So y squared plus 7/9 squared is equal to, well, the hypotenuse is 1 because we're using this unit circle. Oops, I should have written a plus. Minus 49/81 on both sides. Y square is equal to, I'm just going to leave it like this, 1 minus 49 over 81. Why? Because I still have to take that square root. So y is equal to, and let's type it all in and see, second square 1 minus 49 divided by 81. And we get, oh, they said they wanted to find an exact value. Okay, so here's what I'm going to do. That's just a little bit annoying. What I'm going to do is take that 1 and turn it into an 81 over 81, because that's 1. Minus 49 over 81. So what's 81 minus 49? 32. So we're going to get square root of 32 over 81. And when doing radicals and you're dividing, you have a quotient, a fraction inside. You could kind of split it up like this. Square root of 81 is 9. Now we could simplify radical 32, and I'm just going to do that here using a little tree diagram. I know 8 times 4 is 32, and I know this could break down into 4 times 2. Now these are great because I should really write it like this. I know that this number is really 2. I know that that number is really 2. So I end up with 2 times 2. Well, I end up with all the final numbers, you're multiplying them. So 2 times the square root of 2 is 4 square root of 2. Okay, so I'm not going to do this one because it's literally identical. I will start you off though. If sine of theta is that, so what they're really saying, they're saying if your y value in your point on the unit circle is negative 5 over 6, and they're saying it's in the 4th quadrant, so it's a unit circle, this is your point, make your right triangle, you know the y value is negative 5 over 6, they want you to find your x value. Cosine of theta is really x, sine of theta is really y. Right? Use the Pythagorean theorem. Don't forget that the radius is 1, which is the hypotenuse in this case. Is a right triangle. You know, solve. This is 5 over 6. Okay. Without using a calculator, compute the sine and cosine of 120 by using the reference angles. What is a reference angle? Okay, so let's draw this, and we know this, if this is our point on the unit circle, by the time it gets here, that's 90 degrees. And how much more does it have to go to get to 120 degrees? Well, 30. Alright, so we know that this angle here is 30. Notice which angle that is. That's not the reference angle. So this is my right angle. I should have made this a little bit bigger. Let's see if I could just zoom in. So that's 30 degrees. How much is this extra angle down here? Well, it must be 60 because we know that altogether this must be 90, so that has to be 60. So our reference angle is 60. In what quadrant is this angle? You can see it's in quadrant 2. So sine of 120 is, well, since we know that angle is 60, let's draw our reference angle and the reference triangle. And there are 2 of them that you should know. There's a 30, 60, right? Because it has to add up to 180. And then you have your other one where the 2 angles look more equal because they are 45 and 45. For the 45, 45, 90 right triangle, the 2 sides across from the 45 are both 1, and then the right angle is the square root of 2. And then for the reference angle of 30, 60, 90, well, the shortest side is across the smallest angle, I know my picture doesn't represent that, but since the smallest angle is 30, this is going to be 1. Now remember, the right angle is the largest one, so that's going to be the largest number. So that would be 2. And across 160 is the square root of 3. Alright, so memorize these two similar triangles. You'll be using them for a long time. So we're going to focus on this triangle and figure out what the sine of 20 is. So the sine of 120, which is really just the same as the sine of 60 because that's our reference angle. So sine is opposite over hypotenuse, so that's square root of 3 over 1. I'm sorry, hypotenuse is 2. Square root of 3 over 2. Let's do the same thing. Cosine of 120, so we're looking at the same angle. I'm just going to draw it over here. And cosine is adjacent over hypotenuse. Alright, I'm just going to write SOHCAHTOA over here so you can see it. So, whoa. Okay, I lost all that work, but that's okay. I didn't lose the video. So I'm just going to redraw that little triangle. $30, $60, smallest side is 1, the largest side is 2, and then the square root of 3. So cosine of 120, the reference angle is 60, so that's the angle we're looking at. So it's the same as the cosine of 60. And SOHCAHTOA, so it's adjacent over hypotenuse. Adjacent is 1, hypotenuse is 2. And remember, in this quadrant, cosine is negative, so it's negative 1/2. Without using a calculator, compute the sine and cosine of this. So it's the same thing as before, except that they give it to us in radians. Now, no big deal, because we know how to convert between radians and degrees. So what is the reference angle? And they want the reference angle in radians. Let's convert the 7 pi over 6 radians to degrees. So that's 180 over pi. Pi's cancel. 6 into 6 is 1. 6 into 180 is 30. So this is 210 degrees. So let's see where 210 degrees would land. Well, we know this is 90. We know that's 180. And if we went all the way to the end, that would be 270. So let's just say all of this here is 210. So what's that reference angle? Well, let's subtract away the 180 from the 210 and see what that would give us. So 210 minus 180, and that's 30. So this reference angle is 30. Now let's convert, since they want it in radians, let's just convert that 30 back to radians. So I'm just going to write the degrees right next to it, so I know it's 30 degrees. And I also want to write it there so that I could see where it cancels. Pi radians. So degree cancels, the 0, that 0 cancels, 33 is 1, 3 into 18 is 6. So you get pi over 6 radians, which is exactly what we have there. And what quadrant is this angle? You can see it right over here. So in quadrant 3. And now they want to know what the sine of 7 pi over 6 is. Well, let's just convert this thing here to degrees. Pi's cancel. That's 30. Oh, is that the same thing as above? I didn't realize that. So this is really sine of 30. So what triangle are we using? Yep, this time I'm gonna put it correct, because remember the short side needs to be across on that angle. 60 and 90. 2. The shorter side is 1. Square root of 3. Okay. So we're focusing on this angle, the 30-degree angle. Sine, I'm going to write SOHCAH. Don't really need a TOA, but I'll write it anyway. So sine is opposite over hypotenuse, which is 1 over 2. But notice what the angle is. CAST. It's in the tangent quadrant, so we know it's going to be negative. It's exactly what we have. Now this is just the same as cosine of 30. So cosine is adjacent over hypotenuse. Adjacent is square root of 3. And hypotenuse is 2. And again, it's in the tangent quadrant, so it's also negative. And we can see that's what we have there as well. If theta is 1 pi over 6, then sine of theta is, well, let's convert pi over 6. Oh, low battery. Let's convert pi over 6 radians to degrees. Units cancel, that cancels. 6 and 6 is 1, 6 into 180 is 30. So that's actually just 30 degrees, just like we did before. But here's the thing, this is straight 30 degrees. So we know it's going to lie in this first quadrant, 30. Just going to draw my triangle here. So that's 30, we know this is 60. We know that's 90. Short side is 1. This is not a unit circle, by the way. 60 across from that would be the square root of 3. And then across on the right angle is 2. So sine of 30, this is the same thing as saying sine of 30. And that is opposite over hypotenuse. And we know they're all positive here, because it's CAST. They're all positive in this quadrant. So 1 over 2. Cosine of 30 is adjacent over hypotenuse. So that's square root of 3 over 2. Okay, same thing here. So theta is that. Let's convert that to degrees. Pi's cancel. 23 is 1, 3 into 180 is 60. 6 5s are 30, so it's negative 300 degrees. So when you're doing negative degrees, now we usually go in that direction. Nope, negative means we're going to go in the other direction. So this is not negative 90, negative 180, negative 270, negative 300 lies somewhere here. So if that's 300, then the remaining to come back to the start would be 60. So the reference angle is 60. So that means this angle is 30, that angle is 90. Okay, so this is really, and it's in the quadrant where they're all positive. So this is the same thing as saying sine of 60. So sine with respect to this angle. The side across from the smallest angle is 1. Then this is square root of 3, and this is 2. So sine is opposite over hypotenuse, that's square root of 3 over 2. And cosine of 60 is adjacent over hypotenuse, which is 1 over 2. Okay, so I'm not going to do this one. You could try this one for yourself. You see the answers. Find an angle theta where it's between 0 and 360 that has the same sine as 10 degrees. Okay. Between 0 and 360 that has the same sine as 10 degrees. Well, 10 degrees is like that much, right? So it's very little. So, I mean, if I could get that 10 degrees on this side, it would be the same thing. And we know sine over here is positive. Just gonna write my cast. So that's really the same thing as 170 degrees. And let's do the same thing for cosine. So, you know, cosine is positive in this quadrant. So we need a reference angle of 10 degrees here. So that means we have to go around all the way this way, 350 degrees, right? 10 degrees less than that full 360. Okay, that was a weird question, but pretty cool. Negative 30, negative 16. So negative 30, negative 16 is somewhere here, right? I went 30 back this way, and I went 16 up that way. So this is the point, negative 30, 16. Let's make a little right triangle. This is our reference angle. Now notice this is not a unit circle, so I'm not going to put 1 as the hypotenuse. And that tells me that this distance is 30 and this distance is 16. Because remember, I went 30 to the left, 16 up. They want us to figure out what all these things are here. We will need the hypotenuse for that. So let's use the Pythagorean theorem. 30 squared plus 16 squared is equal to x squared. Plus 900 plus 256 is equal to x squared. 6, 5, 1, 1 is equal to x squared. Square root both sides. And since they want an exact value, we're going to leave this as the square root of 1156. So Katoa, sine of theta is opposite over hypotenuse, 16 over square root of 1156. Let's just type it in and see if we get that crazy decimal. 16 divided by the square root of 1156. And yes, we do. Cosine is adjacent over hypotenuse, so it's just 30 over the square root of 1156. But here's the thing. Cast, C-A-S-T. Is cosine positive in that quadrant? No, it's not, so it's a negative. And notice that the answer had a little negative right there as well. Tangent, we know the answer will be negative right away. Tangent is opposite over adjacent, so that's 16 over 30, negative 16 over 30. Here's what we need to know about cosecant, secant, and cotangent. Sine of theta. If we have sine of theta, we call 1 over sine of theta the cosecant of theta. If we have cosine of theta, we call 1 over cosine. You want to guess what it is? That's right, secant of theta. And then tangent, 1 over tangent of theta is really cotangent. So what should cosecant be? Yeah, we just look at the sine of theta and we flip that fraction around. So square root of 1156 over 16. Let's just type it in and see if we're getting that. And the quadrants remain the same. Wherever that's positive, 1 over that will also be positive. Square root of 1156 divided by 16, and you get that number. So guess what secant would be? Yep. You just, well, it's negative. You flip the fraction, 1156 over 30, and then cotangent would be negative 30 over 16. Which function is odd or even? So sine looks like this, right? And it goes this way. So sine is odd because an odd function is symmetric to the origin. Let's do cosine next. So if sine is odd, cosine is even. Right, because cosine Cosine looks like this. Kind of like that. And that's symmetric to the y-axis. So secant, which goes along with cosine, is also even. So what do you think cosecant is? Yep. So it's the same thing as the original. So that leaves us with tangent. Tangent is odd. So cotangent will be odd as well. Okay? And that's it for this video. Catch you in the next one.